Hello, I'm Mark, and welcome to my Unreal Engine tutorials on how to build a simple networked physics-based movement component for your Unreal Engine games. So, as you can see right here, I've got a simple cube flying around using a networked version of our physics-based movement component that we built in the first two videos. So you can see it's flying around. There's a little bit of lag in there on the frame rate, but as you can see, it's moving. And it's moving both across the client and across the server. So when I was originally planning to do these videos, I was going to do this as a single video, but after kind of reviewing all the material that I'd need to be covering, I decided to let's go ahead and break this up into two parts. So again, the first part, we're going to go into C++. We're going to go ahead and create the basic networked version of our movement component. And then we'll also be creating the data transfer objects needed to replicate the data that we need to replicate across the network in order for us to be able to move this object in the way that you can see that we're doing right now. All right, so and then in part two, we'll then go back into blueprints and build out this component, make all the project settings and blueprint settings so that we can use the physics prediction and network replication in order for us to move a physics body across a network. All right, so as usual, we got a lot of ground to cover. And so let's get started. So I'm just going to go ahead and stop this real quick. And I'm just going to move my demo off screen. All right, so let's do a quick little recap from what we've previously built. So again, in the build script, we added two dependencies, the physics core and chaos dependencies. So we've added that to our project so that we can use the network prediction as well as the physics core, so that we can do physics movement within our solution. And then we created our deferred forces loader, which allows us to store the forces that we wish to apply to a physics body and then execute them when we're ready to execute them. So that's there. And then finally, we created our physics movement component. And then while we were here, we also added a couple of little extra pieces in for a network. And that was right here, the network physics component. So this is the component that Unreal Engine has that we can use out of the box, which will allow us to move a physics body across on the network. So we will be implementing this today within our codebase. So I'm going to go ahead and just move into the editor, and we can get started on building our networked version. So to do that, I'm moving over to the editor, and I'm going to come into the content drawer. And then under content, we're going to go to C++ classes. As you can see, we've got our physics movement folder, and under there, I'm going to put, we've got our public folder. And then we created this movement folder, and I'm just going to keep that. This has all of the objects that are for our basic physics movement, so I'm just going to keep that in that folder, and I'm going to create another folder so that we can create our networked version. So to do that, I'm just going to go right click and say new class, and we're going to come to all classes. And unlike in the last one where we were just looking for the pawn movement component, here we can actually use our physics movement component instead. So we're going to inherit right off that class. If we can find it. So there it is. So as you can see, here's the inheritance tree, and there's the pawn movement component which we used to create this. And we're now going to be inheriting from this in order for us to be able to then create a networked component on top of that. So I'm going to go ahead and hit next. And then here, let's go ahead and give it a name. So I'm just going to come over here real quick. And for this, I'm actually going to go ahead and name it a object simulation component. So I'm going to change the name just a little bit. And I'm doing this because the way, when dealing with network replication, all of the stuff that when we were doing the simple physics component, we could do that in the blueprint. We're now going to have to move all of that into the C++ so that we can then move that object. So it gets a little bit more complicated. This definitely is a little bit more advanced than just the basics. So I'm just going to call this object simulation component so that I can just differentiate that between the physics movement. But this is built on top of our physics movement component. And under here, I'm just going to add a little bit of structure. So I'm going to say simulation, and then under simulation, I'm just going to say object. So I'm just going to add a couple of extra folders in here on this object simulation component. And I'm just going to keep this public. So let's go ahead and create this class, and hopefully we'll get a good compile. First compile of the day usually is the slowest. And there it is. It's moving forward. And will it be a success? All right, good, compile. So let's come into the physics movement. I'm going to go ahead and hit reload. And so what we've done, so Unreal Engine's went ahead and created us the base component. As you can see, it's now inheriting from our physics movement component. So I'm going to put this one, like I did in the last one, we're going to put this one to the side because we also need to create the network data transfer objects. So I'm just going to hit save real quick. And we're going to come back to the Unreal Engine editor, and we're going to go ahead and create those network replication objects. So under here we have movement, now we have simulation, and under object we've got our component here. And then I'm going to right click because I want to keep these two together. I'm going to say new class. So these are going to be structs, and so again, Unreal Engine, they don't have a template to build out structs, so we're just going to go under none. And I'm just going to hit next. And I'm going to go ahead and call this our object physics movement traits. That's the name I'm going to give this. And this will become a little bit more apparent as we kind of get further and further into creating our network component. But so these are the movement traits that are going to be going up and down, replicated to the server and back to the clients. Through our network replication. So again, object physics movement traits, that's what I'm electing to call it. And let's go ahead and create this class. Hopefully we'll get a good compile. All right, good compile. Let's move over. All right, so as I said, I'm just going to go ahead and remove this since we're not going to need that. This is a class. What we really need is a struct, so I'm going to go ahead and convert this to a struct real quick. And I'm just going to leave this struct just as it is. The only difference is I'm going to put an F in front of it, so we've got the F prefix. Hit save. All right, so this is our movement traits, and we will come back to this again because we need to build some additional structures or structured objects that we are going to use to then create this movement trait. All right, so to do that, I'm just going to bring in some includes real quick. So the two includes that we need here, we need the physics.network physics component. So this is a reference to the components that we're going to be using to transfer this to and from. And we're also going to create this. I'm actually going to go rename this one to this guy here and take the F out. So this is the object physics movement traits, and this is the generated.h. So we will be using some generated structs here but this one will not be generated. All right, so next we're going to need two additional structs. And so I'm just going to go ahead and copy. So the first one I'm going to create is going to be our object simulation inputs. So this struct is going to hold all of the inputs that we are putting in for that particular movement on that frame. And this one is going to have a generated body. So, and within here, we're going to need a constructor as well as some properties. So I'm just going to add the properties first. So we're going to be putting in the throttle input X, the Y, the yaw input, and as a bonus, I'm going to put a boost count in there too, so we can play with the impulse a little bit in this video. All right. Then we're going to use a constructor and a deconstructor. So I'm just going to add those up here. And all this constructor is doing is it's just going to automatically set this to 0, this to 0, that to 0, and the boost count to 0. So on first construct, we're just zeroing these out. And this is just another way of just, setting these up as 0, to initialize them. And then finally, I'm going to add a quick little function on the input to allow us to reset these inputs. So again, just like in the blueprint that we did in part 2 of the physics movement component, once we've used these to create our forces, we then need to make sure that they get consumed. Otherwise, we could end up with some dirty data in there on the next movement. All right, so and I'm just going to put that right there in a function. Keep it close to where the data is. All right, so then the next struct we need, so that's the input. So we also need a state object. So this is going to be the state, the current state. So this is the input that we need to create for our forces, but we also want to preserve the state as well. And for that, all I'm going to do is I'm just going to say travel direction and previous jump count. So these are our state. This is the states that we want to preserve with this input as we send it up and down the network. And just like with inputs, I'm just going to minimize that. We're also going to go ahead and just set this to a 0 rotator on initialization and then set this to 0. So this is previous jump count. Jump count is going to be our boost count. Little dirty programming there. Okay, so now that we've got that, so these are our two basic structs, and these two structs are going to actually live within our component when we get back to our component. But now we need the data transfer object, so we can transfer both the inputs and the state along the network. And so to do that, again, I'm just going to go ahead and copy this empty little structure. Oh, and before I forget, let's make sure we put this generated body right here. Oh, and since we're generating the bodies again, otherwise the compiler is going to have a hissy fit. We just need to make sure we put those ustructs. So whenever we're using a generate here and a generate body, we need to make sure that we have this here. But as you can see, these are not blueprintable, so I'm just going to keep those empty. Alrighty. So we've got that. Let me just double check. So before we move on, make sure everything looks good. We've got the tag. We've got the macro. That looks good. Just comparing it to my other project. And then we've got the same for here. We've got struct, generate body. Constructor is there, destructor is there, property. Yep. and we should make that a property too. Just kind of keep things together. All right, so now that that's all defined, let's go ahead and define the next thing, which will be our network physics data packages. So to do that, so we've got our struct here that we copied. Just going to minimize that for now, and let's go ahead and convert this into a networked physics data. So to do that, I'm just going to go bring this over as is. So what I've got is, so I'm going to create this object net phys move state. That's what I'm calling it. And it's going to inherit from network physics data, which is housed up here in the network physics component. So we're going to inherit from this object, and then we're going to add our own stuff in here. And what are we going to add? First off, we're just going to go ahead and add our simulation state here, and also, since this is a generated again, we need to put the struct there. So this one is going to be our movement state, so it's going to be taking this object here, and that's what's going to be housed in this data transfer. And then we've got some functions that we need to add in here to help us manage this state. So I'm just going to copy them all in, and I'm including the notes. That way you can get an idea of what they do. And I kind of took this same kind of concept when I was looking at the chaos movement code. So that's kind of what we have here. So again, apply data, build data. So applying, and we'll get into this when we go and fill out the implementation. But that's what just needs to be in there. And technically all of this is public, so I'm just going to leave that there. And then lastly, I'm just going to bring this whole structure over as is. And then lastly, we have this template structure in which we have the object net physics movement state and this movement state. So these are the traits, trait base 2. And again, I'm not a network guy. I really can't explain this, so I'm not even going to try. But it's something that's just needed in order for us to create our physics movement traits object down here. All right, so that should be it for movement state. I'm just going to minimize this for now, and we'll get back to the implementation once we're finished with the definitions. So next up, again, just like we did for state, we need to do the same thing for inputs. So I'm just going to grab that. I'm going to put the struct up there. Just going to copy this over real quick. So again, object net physics input now. So we have one for state and we have one for input, but they're inheriting from the same base class. And I'm just going to move all this over at once, and we'll knock out the public. And again, so we have the object simulation inputs, that's the input movement. And again, I've got the apply, and it's the same structure. And these are all virtuals, so we'll be overriding these functions. And they're all being inherited from the raw physics data. And then finally, just like we did for state, we need to do the same thing for the inputs. And again, so we have this template structure here. And then finally, we can now, after all of that, we can come back down to our struct here. And this one doesn't require generation and doesn't require struct because this is actually going to be going up and down the network. And I'm just going to go and bring these over as is. So again, this is using it. We're going to be doing this using so inputs type, and it's going to be the object net simply. This is for net sequence, the object net physics movement inputs, and that's going to go in inputs type. And then we have the object net phys move states, and then that's going to go into states type. All right, so that's a lot of network data. object structures. So let's go into the implementation. So let's come back up to inputs. So first off, let's go ahead and just implement the reset inputs. So I'm just going to go ahead and show potential fixes. And for this one, it's pretty simple. All we want to do is for the X, Y, and the yaw, we're just going to reset these to zeros again. And that's it for that one. So next up, we're going to go into state. So let's go to the movement state. So as you can see, we've got 1, 2, 3, 4, 5, 6 functions that we need to define. So let's go ahead and I'm just going to go ahead and fix all of this first, and then we can go in and implement it. So this again is for state. All right, so so let's go ahead and get this set up. So for state, so for the first one, this is apply data. So and we are going to need a couple of includes here. So the first one is going to be a reference to our components. So the component that we created, that we're going to create, and the simulate and this data component are kind of tightly coupled. So we need to just create that tight coupling here. So I'm going to say pound include. I'm going to find simulation under object, and there's our, nope, we already have that one. We want the other one, the component. Okay, so we have that. And then the only other thing that we need is the physics proxy, single particle physics proxy.h. All right, so I'm going to minimize that since we don't need this. We're focusing on these functions right here. So now that we've got that set up, so the first thing we want to do is, I'm just going to bring this over. And as you can see right now, the simulation state is not defined. So I'll tell you what, let's go ahead and do that real quick. So let's go back up to our component.h. So under the generated body, let's just go ahead and just quickly just finish this a little bit. I'm going to put this so that it's spawnable component so we can see it in the editor. So that's what that tag's going to do. Under movement, so you can see it's inheriting from that base class. I'm going to add an include for our simulation / object, and this is going to be looking at the traits file because that's where our input state and our inputs and states are going to be located. So I'm going to just finish setting this up. Protected, and just say public. All right, so under public, we're just going to add two properties. So what's happening on the other side in the other file is it's saying, hey, I'm looking for simulation input and simulation state, and it's not there in this object. So we're just going to satisfy that by just adding these two in. So there's our simulation inputs, and then that's our simulation state. And they're public, so they can be accessed easily by the other struct. So now if we come back to here, now the red squiggly's gone away, so there's simulation state, there's simulation state. So what this is doing is we're just taking our network components, casting it, and we're saying this is the data that's coming down the network, and we're going to be parking it into the simulation state here. So, and then the next one, so the next one that we're going to be working on, so for build, it goes the other way. So this is going to be saying, here's the data that is currently in my component, and we want to then move it into the data over to here so that we can then pass this down the network. So it's just the opposite of apply data. So applying data just applies the data coming in, and then build data goes ahead and builds the data that's going to be sent back out. So decay for state objects, I don't think we really need to worry about decaying the state. So, but I'm just going to put this decay amount there for this. And then net serialization, again, we really don't need to worry about serializing the state, so I'm just going to just hold that there. Any interpolation, really there's no interpolation there, but I'm just going to go ahead and just hook the merge data into the interpolation, just so it's there. And I'm just stubbing this out, even though it doesn't really make much sense for the state. We'll just keep the pattern the same. All right, so that is for the state object. Let's go ahead and do the same thing for our inputs. And so let's go ahead and fix these. All right, so we've gone ahead and fixed this. So now we're going to just replicate what we did up here for state for input with some small differences. So again, apply. Again, this is our movement input data. Let's do that to color code it. And again, it's looking in the physics mover, which is technically there, back on the component. For our build, again, it's just the reverse. All right, for decay, we're going to do something a little different. And I'm just going to bring it all over first. So on the inputs, we're going to go ahead and put some decay in there as it's moving. So as you can see here, we've throttle input X, Y, and Z. So what we're going to do is we're just going to go ahead and adjust this by a decay amount. So we calculate the decay amount, and then we're just going to do a lerp, and it's going to be based on the current throttle amount and the amount here, and then we're just going to decay that over time. And we're going to do that for both X, Y, for the X throttle, Y throttle, as well as the yaw. And this is just a standard decay, and I kind of picked this up when I was looking at the wheeled vehicle movement component and how that was kind of working. Net serialization, again. And oops, I also need to have this guy here. So again, net serialization is going to take the archive and output the success. So again, and all we're doing is we're just taking the inputs and then we're just doing a shift into this archive structure here. Interpolation, again, something that I picked up when I was looking at how the chaos vehicle movement component was working. So the interpolation data, again, the physics data, network physics data coming in. So we have a min, we have a max. And so what we're going to do is we're going to set our min input, max input, and we're going to just do we're going to check the frame rates, and then we'll then add that interpolation in there. So again, and we're just going to interpolate from one to the other based on the local frame rates. All right, so that's there. And again, we're just doing that on the X, Y, and on the yaw input further. And then finally, we have, again, the merge data. So when this gets called, then this is what it will do. It's just going to interpolate the from data to the this data. So network data is going to interpolate the network data coming over the network versus the what's happening on the object. All right, so that should do it for all of our networked objects. So I'm just going to go ahead and minimize that. Now let's go back to our object simulation component. So we've gone ahead and put the simulation input and simulation state in there. Now we can come into the protected and the public. And so since we've put a lot of the base functionality in the physics movement component, and we're inheriting from that, that actually makes our life a little bit easier when coming over to the object simulation. So when we were building out the physics component, we created these two virtual functions, I should say. The first one is the initialize network physics movement, and then the second one is the simulate physics tick. And these two functions, let me go ahead and find that code, map to functions that are up in here. So we have the onCreate physics, and then we also have our physics state, our physics tick. So rather than just replacing all the work we did in here and replacing all the work we did here and then pretty much duplicate it all, what we do is we just created these two little hooks. And so the way this is going to work, since we're doing a virtual override, we can override these virtual functions. We're going to say, as this is executing, don't execute the function that's defined in the class. Instead, execute the function that is defined in the inherited class. So this is the initialized network physics movement. And then again, we have the simulated physics tick. So this is where we actually will do the simulation code right here on the thread right there. So let's go back to our object simulation. So we'll just hold off on implementing those real quick. So the only other things I'm going to go ahead and add here are going to be the inputs. So this is how we're going to be setting the inputs, simulation inputs. So to do that, rather than do this in the blueprint, we're actually just going to pass those values straight in off the action inputs, and we'll handle all of that within here. So again, we've got input X, inputs for X, Y, yaw, and then we're just going to add our impulse boost, which is our jump. All right, so now that we've got that done, let's go ahead and define these functions real quick. Okay, so the first one, this is our initialization. So this is going to be executed within the create, within our create physics state. So if we come back here and we go to here, so all we're going to do here is copy this. I'm just going to bring this over. So all we're going to do here is we're going to say is using network physics prediction. So that's a function that again is on our physics movement component, and that's going to check to see if prediction is turned on. And if prediction is turned on, then we're going to say, okay, well, let's make sure that the base class, right, created our network physics component. If it did, great, wonderful. Then what I'm going to do is I'm just going to run this same function again so I can get access to it. And then off there, I'm just going to use this pointer reference. And as you can see, there's a lot of other information in here. And we're just going to use the create data history. And from there, we're going to use the object physics traits, which we defined in the previous file. And we're just going to pass in a pointer to the components that we want it to get the data from, so that it can, or broker the data. So this is acting as our data broker, sending data up and back through the network. All right, and before I move on, I'm just going to add one more include, because we're going to need this when we get to the simulation parts, and that is going to be the physics proxy single particle physics proxy.h. So I just added that there. All right, so that's the initialization work. So that needs to be done on creating the physics state for networking. And then we have the simulate physics tick. So I'm just going to say show potential fixes. And on here, so the first thing I'm going to do here, so this is going to be how we're going to be executing within the physics thread. So the first thing I'm going to do is we're going to do an update of the physics state. So in the blueprint that we did in part 2, we did that on the tick event on the game thread. Here we're going to be doing it on the physics thread. And where we're going to get this rotation from, so instead of passing that rotation as an input, we can actually get that straight from the rigid body handle here. And that is located in this cryptic R function. So as you can see, there's a lot of cryptic functions in here. Some are pretty well defined, others are, take a little bit of trial and error to figure out what they do. So R is the rotation. And so what we're going to do is we're going to take the rotation, and it's using a F rotation 3, and we need to convert that to a rotator. So we're just going to convert that by just parking that in there, creating the rotator, and then putting that into the travel direction. So that's how we're updating the travel direction state. Next, we're going to need to figure out what direction we're actually going in so that we can calculate our forces that we need to add. So to do that, we're just going to do this. So we have vectors, desired forward directors. So we're just going to take the travel direction, get the vector that it's going in, that's the forward vector. The right vector, we're just going to do a rotational matrix on the travel direction, and then we're just going to say get scaled axis, E axis on the Y. And that's all we're going to do there. And then for the up vector, we just do the same, but instead of the Y, we're going to use the Z. So that should get us the vectors in the right direction based on the rotation, based on where the physics body is being rotated into. All right, so for impulses, this is pretty simple. All we're going to do is we're just going to take the number, so previous jump count, or this could be the previous boost count again. A little bit of dirty data in here. And all we're going to then do is we're just going to say there's the desired up vector. That's the direction we want to boost in, so we're going to always boost up. And then by the magnitude. And then I'm going to set this one to false. So this is actually going to go in as a force and not as an acceleration. So a little bit different there. But that should jump the cube up whenever we tie it into the jump button. All right, next we're going to calculate some forces and torques. So just like in the blueprint, we've got the add force here. Again, this is part of our use physics, so we might as well just call it there. Simulate inputs. So there's our throttle axis coming in. There's our, that's how we're calculating the desired forward director. And then this is our magnitude, and then again we're going to treat these as accelerations versus actual true forces. So X, Y, and this is the input. And we'll set that, and this is the yaw input. So that's how we're going to be calculating our turning left and turning right. All right, so once that is done, actually, you know what? I'm actually going to put this up here instead, since this is everything that has to do with impulse. So I'm just going to add this simulate. This is the previous count. So what we're doing here is we're checking to make, if these are unequal, then we've clicked the button and we need to do a jump. Otherwise, if they are equal, that means we've already jumped and we don't want to jump again. And we're just going to make sure that we set the state. So we're tracking the state there. All right, so once everything has been loaded up, we're now ready to execute our forces. So everything's been loaded into the deferred forces loader, and now we just need to apply the forces. And then once we've applied it, we need to consume the inputs. So we'll just consume the inputs through our inputs reset inputs function. And that should do it for simulation on the tick thread, on the asynchronous tick. Whoops. Ah, good old Microsoft. Yay. All right, so let's go ahead and finish off our implementation. So what we have now is we've just got this set throttle input for X, Y, and your input as well as boost. So to do that, all I'm going to do is I'm just going to say show potential fixes for these. And we'll do it for this since they're all relatively the same. Just going to minimize that and minimize this. So all we're going to do here is we're just going to map the incoming value to the input in the input structure. And while we do that, I'm also just going to, we're just going to run a clamp as well. So we want to make sure that this value is between -1 and 1, right? So we're just going to ensure that the value is between those two values, and then if it is, and then clamp it if it's outside of those two values, and then put that into the X. And we're going to do the same thing for the Y. Again, clamp it so that we make sure we've got a true Y throttle value. And then for your input as well. So we do our test. And then for the, as far as the boost or the impulse boost or the jump, all we're doing is we're just incrementing the inputs. So we just increment the input value there coming in, and that's all we're going to do there. And that should do it for our networked physics component. So I'm going to go ahead, so let's go ahead and compile it, make sure we've got a good compile first. Busy. All right, good compile. Okay, so I'm going to go ahead and stop the video here. So that should do it for our component. So in the next video, we'll go ahead and come back to the editor, and we'll go ahead and build the networked version of our physics movement cube, and then set up the project so that we can facilitate network replication for that cube. All right, so again, if you like what I'm doing, feel free to like and share my videos, as well as subscribe to my channel, and I will see you again in the next video. Cheers, bye.